Solve the system. X minus 4 is equal to 3y, and x squared plus y squared is equal to 8. The first equation is the equation of a line, and the second equation is the equation of a circle. By visualizing the graphs, we can see that we'll either have 0, 1, or 2 points of intersection. To solve this system, we'll use substitution. We can solve the first equation for x by adding 4 to both sides and getting x is equal to 3y plus 4. We can then substitute this expression for x into our second equation. When we do that, we get 3y plus 4 squared plus y squared is equal to 8. Squaring 3y plus 4 on the left side, we get 9y squared plus 24y plus 16 plus y squared is equal to 8. Combining like terms, we get 10y squared plus 24y plus 16 is equal to 8. And we'll then subtract 8 from both sides to get 10y squared plus 24y plus 8 is equal to 0. Notice that we have a common factor of 2 that we can factor out on the left side and then divide both sides of the equation by 2. When we do that, we get 5y squared plus 12y plus 4 is equal to 0. We can then factor the left side as y plus 2 times 5y plus 2, which is equal to 0. Using the zero factor property, we know that y plus 2 equals 0 or 5y plus 2 equals 0, which tells us that y is equal to negative 2 or y is equal to negative 2/5. To find the corresponding x values, we'll use the equation that we obtained, x equals 3y plus 4. So when y is negative 2, x is equal to 3 times negative 2 plus 4. And so x is equal to negative 6 plus 4, or negative 2. When y is negative 2/5, x is equal to 3 times negative 2/5 plus 4. So x is negative 6/5 plus 4. And so x is equal to 14/5. Thus, our two solutions are the ordered pairs negative 2, negative 2, and 14/5, negative 2/5. We can check each of these solutions by substituting the x and y values into both of the original equations and verifying that true statements result. So the solution set is the set containing the ordered pairs negative 2, negative 2, and 14/5, negative 2/5.